Good day, students. This is Teacher Steph, and welcome to our science class. For today's lesson, we'll be discussing one of the most important concepts in chemistry, the rate of chemical reaction. In this video, you'll be able to use simple collision theory to explain the effects of concentration, temperature, and particle size in the rate of reaction. Specifically, after watching this video, you will learn the different factors affecting the rate of chemical reaction and why they affect reaction rate. But first, let us know and understand what a rate of chemical reaction is. So what does rate of reaction mean? The reaction rate or rate of reaction is the speed at which a chemical reaction takes place. The speed of different chemical reactions varies usually. Some reactions are very fast and others are very slow. But why are some reactions faster than the others? What then determines the rate of reactions? Reactions take place when particles collide with a certain amount of energy. The minimum amount of energy needed for the particles to react is called the activation energy and is different for each reaction. The rate of reaction depends on two things: the frequency of collision between particles and the energy with particles collide. Take note that if particles collide with less energy than the activation energy, they will not react. The particles will just bounce off each other. So anything that increases the number of successful collisions between reactants will speed up a reaction. What factors affect the rate of reactions? Temperature, concentration and pressure, surface area, and the presence or use of catalyst. How does temperature affect the rate of reaction? The higher the temperature, the faster the rate of reaction. In many reactions, a rise in temperature of 10 degrees Celsius causes the rate of reaction to approximately double. Why does increased temperature increase the rate of reaction? At higher temperature, particles have more energy. This means they move faster and are more likely to collide with other particles. When the particles collide, they do so with more energy, and so the number of successful collisions increases. Let's proceed to concentration. How does concentration affect the rate of reaction? A higher concentration of reactants leads to more effective collision per unit time, which leads to increased reaction rate. In other words, the higher the concentration of the solved reactant, the faster the rate of a reaction. Why does increased concentration increase the rate of reaction? At higher concentration, there are more particles in the same amount of space. This means that the particles are more likely to collide and therefore more likely to react. What is the effect of pressure on rate of reaction? Increasing the pressure of a reaction improves the likelihood reactants will interact with each other, thus increasing the rate of reaction. As you would expect, this factor is important for reactions involving gases, and not a significant factor with liquids and solids. Why does increasing the pressure of gaseous reactants increase the rate of reaction? As the pressure increases, the space in which the gas particles are becoming smaller. The gas particles become closer together, increasing the frequency of collisions. This means that the particles are more likely to react. What about surface area? How does it affect the rate of chemical reaction? Any reaction involving a solid can only take place at the surface of a solid. If the solid is split into several pieces, the surface area increases. What effect will this have on rate of reaction? This means that there is an increased area for the reactant particles to collide with. The smaller the pieces, the larger the surface area. This means more collisions and a greater chance of reaction. How does a catalyst affect the rate of chemical reaction? What are catalysts? Catalysts are substances that change the rate of reaction without being used up in the reaction. Catalysts never produce more product. They just produce the same amount more quickly. Catalysts work by increasing the frequency of collision between reactants, altering the orientation of reactants so that more collisions are effective, reducing intramolecular bonding with reactant molecules or donating electron density of the reactants. The presence of a catalyst helps a reaction proceed more quickly to equilibrium. Different catalysts work in different ways, but most lower the reaction's activation energy. To recap, rate of reaction is the speed at which a chemical reaction takes place. Activation energy is the energy level that the reactant molecules must overcome before a reaction occurs. In general, a factor that increases the number of collisions between particles will increase the reaction rate, and a factor that decreases the number of collisions between particles will decrease the chemical reaction rate. Therefore, increasing the temperature, increasing the concentration of dissolved reactants, increasing the pressure of gaseous reactants, increasing surface area of solid reactants, and using catalysts will increase the rate of reaction.